All right, everyone. The previous lesson, we graphed quadratic functions in vertex form. Now we're going to be graphing quadratic functions in standard form. Before we write standard form, I want to show you where standard form comes from and how vertex form and standard form, you're graphing the same function. Just like linear functions can be graphed using point slope standard and slope intercept form, vertex and standard form and quadratics are interchangeable, and you're going to see that here. So what we're going to do is we're going to take this function ax minus h squared plus k, and we're just going to expand it. By expanding it means we're going to take this x minus h and square it, and then we'll distribute our a. So after we FOIL this out, we get x squared minus xh minus xh, which would be minus 2xh, plus h squared plus k. Now we're going to distribute our a, ax squared minus, I'm just going to write this as 2ahx, a can go anywhere in there, plus ah squared plus k. And then what I like to do is just put a set of parentheses around the a, our minus 2ah, and then this ah squared plus k. Okay, and let's talk about these three values. So standard form looks like this. F of x equals ax squared plus bx plus c. So hopefully you can see here that the a is just the same in both. So a is the exact same in each. It represents a vertical stretch or compression. And if the a value is negative, it can be a reflection over the x-axis. Okay. B is going to be represented by this negative 2ah. So B equals negative 2ah. And then the next thing I'd like to point out here is this h comes from this h in your vertex form. And if you remember, if that was my vertex was hk, then if I solve for h, I can have we'll get the x coordinate of our vertex in standard form. So if we just solve for h, divided by negative 2a, we get h equals negative 2a. Okay, and this gets us something called our axis of symmetry, which we talked about in the previous lesson. It's also the x coordinate of our vertex. Okay. And then last but not least, I'm sorry, I need to fix this equation here. H equals negative b over 2a. My apologies, forgot our h there. And then last but not least, our c is represented by this ah squared plus k. So ah squared plus k equals c. And really, the only part for c that we need to be concerned with, if we were to plug in 0 into our vertex form, we would be left with ah squared plus k. And whenever you plug in 0 for x, same thing down here in standard form. If you plugged in 0 for x, the only thing you'd be left with is c. So really our c equals ah squared plus k. Both of these are just going to get us our y-intercept. Okay. And I'd like to write standard form down here one more time, highlighting the a, b, and c values. So f of x equals ax squared plus bx plus c, where a is just your vertical stretch or compression. It also tells you whether we reflect over the x or over the x-axis or not. So another way we could word that is tells you whether the graph opens up or down. The B is going to get us our axis of symmetry, which is the vertical line that goes through the x coordinate of our vertex. Okay, remember the equation is x equals negative b over 2a, and then c is our y-intercept. Okay, so all three parts of standard form are going to be different components of our graph. They're going to different components of our function. They're going to help us graph that function. Okay, so let's try two examples together, and we'll let you try one on your own. When the function's in standard form, we need to start by finding the axis of symmetry. So we need to use that negative b over 2a. If we're using negative b over 2a, our b is negative 4, our a value is 1/2 here. So a negative 4 is going to get us a positive 4 over 2 times 1/2. So we get x equals 4 over 1, or just 4. So that means we can come over here, 1, 2, 3, 4, put our axis of symmetry. That means this is going to be going straight through the vertex of our parabola. We just need to know where on this line does our vertex fall. And the way we're going to find that is we're going to take that 4 and we're just going to plug it in. We're going to plug it in where you see x and solve for your y. Remember, this is a function. We can plug in any given input and solve for an output. So we have 1/2 times 4 squared minus 4 times 4 plus 3. We get 8 minus 16 plus 3. So a negative 8 plus 3 gets us negative 5. Parentheses there. So 4, negative 5 is going to be where our vertex is located. All the way down here. And then we really don't have to do too much more work here to get another 2 points. The y-intercept is going to be able to get us 2 points because it's going to be the same distance on each side of the axis of symmetry for next 2 points. Okay, our y-intercept here is positive 3. So that's where the graph is crossing the y-axis. And then hopefully you can see, okay, well, that's 4 units away from my axis of symmetry, so I can go 4 units on the other side because we know quadratics, parabolas, they're symmetrical. If I asked you to graph using 5 points, then you can just use plug in a value for 2 more points. And then just pick any value that you like, something that's easy. Maybe you want to pick 2 because we know we're going to have to multiply by 1/2 in front. So let's just plug in 2 and see what we get. We'll just make our little table here. If we plug in 2, 1/2 times 2 squared minus 4 times 2 plus 3. And we get our 4 times 1/2 minus 8 plus 3. So we get a negative 6 plus 3, which is negative 3. We can go graph that point at 2, negative 3, and then you have the same distance on the other side. That's 5 points for our parabola. And it looks like this. Good practice from last section. Domain and range. Domain is all real numbers. Range is everything greater than or equal to the y-coordinate of your vertex, which would be negative 5. Great. Let's try number 2. Let's just do 3 points here for the sake of time. So steps 1 and 2, find the axis of symmetry, and then graph using the y-intercept. Okay, remember our axis of symmetry is negative b over 2a. For this problem, that our b value is negative 12, our a value is negative 4, so we get a positive 12 over negative 8. This is going to give us a negative 3 over 2. Negative 3 over 2 is right here. same as negative 1.5. And then we're going to need to plug that in. I'm going to erase this for a little bit more room. We're going to need to plug that in to go ahead and get the y-coordinate of our vertex. So we're going to plug in negative 3 over 2 squared minus 12 times 3 over 2 minus 3. We get a negative 4 times 9 over 4. Minus 2 goes into 12 6 times, so 18 minus 3. These 4's can eliminate, so we get a negative 9 minus 18. Or sorry, we need to be careful here. That's a negative 3 over 2. So that would be our positive 18. We get negative 9 plus 18 minus 3, which gets us a y-coordinate of 9 minus 3 of 6. So negative 3 over 2, comma 6. Let's go plot our vertex. And then just use your y-intercept for your next 2 points. Your y-intercept is at negative 3, which would be right here, and then the same on the other side. And 3 points is fine for this graph. On the homework, it'd be great if you guys were practicing with 5. We'll have you try 5 points on number 3 as well. But hopefully you can see this graph is really, really narrow, squeezed together because of this 4. Remember, that's a vertical stretch of 4. And then the negative makes this graph open down. Another way we describe that is we say it reflects over the x-axis. Same thing on number 1. This graph was wider than your parent function because that 1/2 is a vertical compression by a factor of 1/2. Okay, let's have you try number 3 on your own graph using 5 points, then list the domain and range, and I'll put the solution up for you guys in just a sec. Okay, for your vertex, you should have gotten a vertex at 3 over 2, 1/4. 3 over 2 would be right here, 1/4, just barely above your x-axis. And then another 2 points. Let's use our negative 2 for our y-intercept. Go 1.5 units on the other side of your axis of symmetry, which would be right here. And then let's plot another 2 points. Let's just use the next ones over, which would be at 1, 2, 3, 4. So let's plug in 4 and see what we get. Negative 4 squared plus 3 times 4 minus 2. Get negative 16 plus 12 minus 2. So a negative 4 minus 2 is going to put us at negative 6. And that's 2.5 units. So let's go 2.5 units on the other side. There's 5 points for this quadratic function. Hopefully you know it's opening down because of the negative. And then this is your parent function, so there is no stretch or compression factor. Okay, the last thing I'd like us to finish with before you get to your homework is graphing using vertex form, and then just expanding it out and seeing you get the same thing if you were to graph using standard. So let's see how much we remember from vertex form in the previous lesson this week. Our vertex would be at 2, negative 4. Remember, whatever's inside parentheses is always the opposite. So we would go to 2, negative 4, our vertex, and then our parent function of values. Remember, our parent function of values, negative 2, negative 1, 0, 1, and 2. We usually get 4, 1, 0, 1, and 4. Well, now we're multiplying by a negative 2 to all of our y's. So negative 2, negative 2, negative 2. So now our y-coordinates would be negative 8, negative 2, still 0, and the same on the other side. So let's go plot those points. Negative 1, negative 2. Remember, in vertex form, you graph those points from the vertex, not from the origin. 2, negative 8. 2, 3, 4, 5, 6, 7, 8. Same on the other side. There's our function. Let's go ahead and expand this out and see what it looks like Maybe we can notice things about our axis of symmetry, our y-intercept, and check our solution. So this would be negative 2 times x minus 2 times x minus 2 minus 4. So we get x squared minus 4x plus 4. We need to distribute that negative 2. 8x minus 8 minus 4. And in standard form, we have a function, a quadratic function that looks like this. Negative 2x squared minus 8x minus 12. Let's check a couple things here. A value is exactly the same, negative 2 on both. Quadratic function's opening down, and the 2 is a vertical stretch. And then remember, this negative 12 is your y-intercept. If you go check down here, 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. We are crossing at negative 12, so we did everything correct in graphing here. Do not forget about graphing in vertex form. And then later on this week, we'll talk about going from standard back to vertex, probably later in this unit, because we need to use something called completing the square. But we'll talk about that later in this unit. Practice on your homework tonight, graphing in standard form. If you have some in vertex, don't forget, use your current function values and graph those points from the vertex. Okay.